All right, this is page 260 of the Incredibles book. There are two versions of this video. You're watching the second version. This is use substitution, the second way to do it, the change of variables way to do it. All right, so here, so what does that mean? So this means this video is a little longer because of the change of variables, but maybe easier to understand. All right, so here, what we're going to do, we're going to rewrite this and change the variables. We're looking for what should u be. U is the variable we're changing it to. U is usually inside of some function. So here x squared plus 1 is inside the function of the exponent of 4. So I let u equal x squared plus 1. Now here's the thing. If you're confused about which one should be u and you have plenty of time, just do it randomly. So, okay, I'll just let u equal what it looks like to be x squared plus 1. If that doesn't work, try the other one. Let u equal 2x. If that doesn't work, let u equal x squared plus 1 to the 4th power. You can let u equal anything and then see what happens. Okay? So then here, we're going to take the derivative, and this is called a differential, right? So when I take the differential of u, a du pops out. When I take the differential of x, a dx pops out. Now look what we got here. We have 2x dx. Aha, so this was the correct choice, right? U equals x squared plus 1, and du equals 2x dx. So that means I can rewrite everything in terms of u. So the 2x dx is just du and u to the 4th. U to the 4th du. And this is something that's easy to integrate. I just add 1 to the exponent, divide by the new exponent. So it's 1/5 u to the 5th plus c. Now, you're not allowed to leave it like that. Okay, so here we're going to rewrite it and replace the u with what we did the substitution for, x squared plus 1 to the 5th plus c. And that's the answer to example A. Let's go on to example B. All right, here we go. Again, we're going to let u equal to the inside function. So u equals x cubed plus 1. So du equals 3x squared dx. And there it is again. There's the 3x squared dx. So that means I can do a substitution. I'm replacing the 3x squared dx with just du. Right? 3x squared dx is replaced by du. And I'm replacing the x cubed plus 1 with u. So it's square root of u. And square root of u is same as u to the half. All right, and then you integrate it. So it's 3 halves. 1 half plus 1 is 3 halves. Divided by the new exponent, 3 halves plus c. So that's 2/3 u to the 3 halves plus c. But we're not allowed to leave it like that. So we're going to replace the u with, what is it? X cubed plus 1. I'm going to use parentheses here. X cubed plus 1 to the 3 halves plus c. And that's the answer to B. That's the answer to B. C, secant squared x, okay? So you might think, and I'm going to do a little experiment here. You might think u equals secant squared. So you can try that. U equals secant squared dx. I'm sorry, secant squared. Then du equals 2 secant x tangent x. Well, that is really not there, is it? Actually, you could do that, but let's try something else. This doesn't look like it's working. So then you try something else. Let u equal tangent x plus 3. U equals tangent x plus 3. That would be du equals secant squared x dx. Right? The derivative 3 is 0, goes away. And look at there. There's secant squared. There's dx. So that means I could do a substitution. Integral of u du. All right? Even the parentheses disappeared. All right. I replaced the tangent x plus 3 with u. I replaced the secant squared dx with du. That's it. So this is u squared over 2 plus c. Go back and change the u back to what it was originally. I'm going to rewrite that over 2 as a half. So it's tangent x plus 3 squared plus c. That's it. Example D. I hope I have enough space here. Okay, so let u equal whatever is inside of the exponent. So let u equal 7x. So du equals 7 dx. So if I do that substitution, I'm out of space over here, so I'm going to write it underneath. So 7 dx is du, and 7x is u, so it's e to the u du. The integral of e to the u du, is just e to the u plus c. Simply replace u with 7x, and that's what we have. E, example E. All right. Remember, you let u equal the inside of some other function. So I'm going to let u equal x cubed plus 4. So du equals 3x squared dx. And looky there, 3x squared dx is right here. So that means that combination is replaced by du. So that's going to equal, let me go down here. So it's integral of du 1 over and u squared. That's same thing as u to the negative 2 du. And then that's negative u to the negative 1 plus c. Right, I'm dividing by negative 1. That's where that negative sign comes from. Remember, negative 2 plus 1 is negative 1. So that's what it is. So that's negative 1 over u plus c. And don't forget to change it back. U is x cubed plus 4 plus c. All right, and then example F. Remember, we're letting u equal the function that's inside another function. You got 2x minus 3 to the third power. So I'm going to let u equal 2x minus 3. So du equals 2 dx. All right, continuing. Let's see what we got here. So I have 2 dx, and that's du, and 2x minus 3 is u. So it's integral of u to the 3 du. All right, replace the 2 dx with du, 2x minus 3 with u. All right, so it's 1/4 u to the 4th. Right, 1/4, same as dividing by 4, plus c. And don't forget to go back and change it back to the original. And that's the answer to F. G. Okay. You might think u equal that, but remember last time when we did that with C, we let u equal tangent x plus 3. Let's try the same thing again. Maybe it'll work, maybe it won't. Try u equal cotangent x minus 4 du. The derivative of cotangent x is negative cosecant squared x, and then the dx. So yeah, there's negative cosecant squared the dx. So I'm going to write it down here. So that's going to equal, that's u. Cotangent x minus 4 is u, and negative cosecant squared dx is du. So it's just 1/2 u squared plus c. Remember to change the u back to the original. So it's cotan x minus 4 to the second power plus c. All right, that's G. Let's do H. Here, let u equal the x to the 4th plus 9. Du equals 4x cubed dx. And there's the 4x cubed dx. So that means those two can be replaced with du, and I'm going to substitute it. So it's square root of u du. All right, and that can be written as u to the 1/2 du. So it's 1, remember, add 1, so that's 3/2. So that's same as multiplying by 2/3. U to the 3/2 plus c. Don't forget to change it back. U is x to the 4th plus 9, 3/2 plus c. And that's page 260, the change of variables version. If you don't like this one, you prefer the pattern recognition, watch the other video. Thank you and good night.